Hello, welcome to Mathematics with Simon. I'm Simon. Today we're going to look at a Maths Olympiad problem on cubes and cube roots. So here's the problem. Cube root of x plus 1 over cube root of x equals 3. What's the value of x cubed plus 1 over x cubed? Okay. So let's start with some notation. We often do this. Notation is so important. Let's say that y is the cube root of x. So y plus 1 over y is 3 because cube root of x plus 1 over cube root of x is 3, so y plus 1 over y is 3. We're going to define a1 as y plus 1 over y, a2 as y squared plus 1 over y squared, an as yn plus 1 over yn. And then we need to know the value of a9, because a9 is y to the 9 plus 1 over y to the 9, which is x cubed plus 1 over x cubed. That is the problem. Okay, so we can just crunch this directly. A2 is y squared plus 1 over y squared, and if we calc it out, what that is the square of a1 take away 2, because here we're going to get the y squared, here we're going to get the 1 over y squared, and then y times 1 over y is 1, y times 1 over y is 1, so we just get 2 to take off, which we can actually write as a0, which is kind of nice, because a0 is y to the 0 plus 1 over y to the 0, or 1 plus 1 over 1, assuming y is not 0. Then it's a bit indeterminate. But the point is, a0 just stands for 2 here. A3 is y cubed plus 1 over y cubed, which is y squared plus 1 over y squared times y plus 1 over y. And you get the y cubed plus 1 over y cubed, but then you also get a kind of 1 over y term and a y term. So here, which is a1, which you have to take off. A4 turns out to be a3 times a1 minus a2. A5 turns out to be a4 times a1 minus a3. An plus 1, when you crunch it, turns out to be an times a1 minus an minus 1. Okay, so we can literally just power this out. So we know that a1 is 3. We know that a0 is 2. So a2 is 3 times 3 minus 2, which is 7. A3 is 7 times 3 minus 3, which is 18. A4 is 18 times 3 minus 7, and so on until we get to A9. We just calculate it out, 5,778. Okay, I'm calling that the direct crunch. The second way is to solve for y. So if y plus 1 over y is 3, we can turn this into a quadratic, can't we? Multiply through by y. So y squared minus 3y plus 1 equals 0, and we're taking 3y from both sides. Multiply through by y and take 3y from both sides. Solve by the formula minus b plus or minus root b squared minus 4ac all over 2a. You get 3 plus or minus root 5 over 2, which is, so if you plus, it's 2.6180. If you take it away, it's 0.3820. And so the answer, x cubed plus 1 over x cubed, you got to take this to the power 9 and this to the power 9. Now, you can do it with a calculator, which isn't really allowed and doesn't really qualify, or you can crunch the surds, which would take forever. So I did it with a calculator, got the same number, but this isn't really a solution. What this shows you is the quadratic root is appealing, but you sort of run into a bunker because you end up in a big complex calculation, which, well, I suppose you could crunch, but it's a horror to crunch, really. And it's not really within the rules of the competition. This is the solution they actually wanted, which is beautiful. The point is, from a previous Olympiad problem, which I'll put in the notes, we worked out that if a plus b plus c is 0, then a cubed plus b cubed plus c cubed is 3abc. So here, I worked this out all on my own, it made me happy. Here, you have this expression, right? That's what we started with. Take 3 from both sides. So cube root of x is a, 1 over cube root of x is b, minus 3 is c. So you cube this, you get x. I mean, it's all comes out so nicely. Cube this, you get 1 over x. Cube minus 3, you get minus 27. Then you got 3abc, which is 3. These two are going to cancel to 1. So it's 3 times minus 3, which is minus 9. So x plus 1 over x minus 27 is minus 9. That means x plus 1 over x is minus 18. And I'm writing it like this because we apply the same rule again. That means that x cubed plus 1 over x cubed minus 18 cubed, or if you like, plus minus 18 cubed, which is the same thing, equals minus 3 times 18, or 3 times minus 18, which is minus 54. So basically the answer we get is x cubed plus 1 over x cubed is 18 cubed minus 54. That's the 18 cubed, that's the 54. 5, 7, 7, 8, same answer. So this was, well, I don't mind the first result actually, because I like a sort of recursive process. The first result was nice. The second result doesn't really work, and the third approach is very economical and sort of quick, and by doing the first two we realized how quick the third approach was. I hope you liked this video. It was so much fun to make. Please hit subscribe and hit the notification bell. I'll send more stuff. I'd love to hear your ideas, and most of all I hope you enjoy your mathematics.